So, hi guys. This is lesson 5. We're in lesson 5. We're graphing systems of linear inequalities. So, the solution of a system of linear inequalities is all of the points that make all of the inequalities in the system true. So, we show this solution, it's going to be shaded. Before, when we're looking at systems of equalities, linear equalities, or lines, two systems, it's the point of intersection. But now we're looking at shading. So things we need to recall. How do we shade? What does shading look like, and why do we shade? Okay, so let's say I have a line. Let's say, let's get another line going on here. So let's say we have two lines here. Two lines. All right. Here's our y-axis. Here's our x-axis. So this is x. This is our y-axis. Over here, this is y, and this is our x-axis. Regardless. So if you have an equation, you have the equation y is less than. What does that look like on this line? If you have y is less than, the y is by itself, then you're shading below the line. Okay? If you have y is greater than or equal to, you're shading above the line. So it looks like this. So below the line, here's all the solutions that are a part of that line. And this is equal to, so the line itself is included. Any points on the line itself is included. And any points in the shaded area are included as well. On the other hand, for greater than or equal to, any points on the line or above the line are included. Okay, so that's the shading. Now, let's talk about, what about the difference between greater than? So y is greater than, or y is less than. How do you denote that? How do you identify that? Well, that's when your dotted line comes in handy, because of the greater than symbol and because of the less than symbol. But if y is greater than or equal to, or y is less than or equal to, our line is solid. So that's from unit 6. Unit 6, okay? Now, also, unit 5. Unit 5. On unit 4, how do we find the slope of a line? Well, let's say, well, how do we write the equation of the slope of a line? Let's say our slope equals 1/2, right? Our y-intercept is -2. So the first thing we do is we graph the y-intercept. We graph the y-intercept. And then we go up 1, right 2. So up 1, right 2. Up 1, right 2. And we continue on until we have that straight line. And we're able to graph our line. A little bit crooked, but it works. But anyways, we're going to graph systems of linear inequalities. So graphing each inequality with the light shading, and then heavily shade the area where they overlap. So we're going to use two different colors for shading. So the first line I'm going to attack is y is greater than x plus 2. And the second line is going to be y is less than or equal to -2/3 x minus 3. And you'll see the solutions, all of the solutions here are going to be green. And you'll see it when you see the overlap. So let's approach these very differently. So for x plus 2, for greater than x plus 2, I'm shading up, and my line type is a dashed line. So I'm not going to include that dashed in there. The slope for this line is 1/1. My y-intercept is +2. So I'm going to graph the first line in red, and go to the y-axis and graph 0, comma 2. And then I'm going to go up 1, right 1, make a point for each mark so it's clear. Okay, so this is my first line. This is y is greater than x plus 2. And remember, I said that this is dashed, so I'm just going to make my dashes on top of my points. They're not connected. And then I'm going to shade above the line because it's greater than. Oh, I don't want to shade blue. Don't want to shade blue. So I'm going to change that color to yellow. All right. Now we're looking for not just a single point, but we're looking where the shaded sections overlapped. Okay? So this is x plus 2. This is x plus 2. Not only x plus 2, this is y is greater than x plus 2. Now my second line, I am shading down because it's less than, and this line is solid. It's solid. My slope for the second one is negative 2 over 3. My y-intercept is negative 3. So I'm going to go to y-axis, graph negative 3, and I'm going to go down to right 3. So down to right 3. If I go backwards, I go up 2, left 3, up 2, left 3. That's all I can go. This is a solid line. Now we're looking for the section, the shaded area of overlap here. We're looking for a shaded area of overlap. I'm shading below this line. If I look, my shaded area is going to turn green. My solution to this particular system is going to be not just one point, but a series of points. So here I have y is less than or equal to negative 2/3 x plus 3. But here in the middle, this green portion, this is a solution of the system. So all points in that area are solutions to the system. All points in the area are solutions to the system. What about the second portion of this? Well, the problem with the second portion, the second system here, is that y is not by itself. So I'm going to go ahead and do that. So I have 3x plus 2y is less than negative 4. So I'm going to move the x term over. Uh-oh, my bad. Move the x term over, and I get 2y's less than negative 4 minus 3x. Divide both sides by 2. So that's each individual term. Y is less than negative 2 minus 3 over 2 times x. So I'm going to rewrite that. Y is less than negative 2 minus 3/2 times x. So here I'm shading below the line, and the line is dashed, and my slope is negative 3 over 2. My y-intercept is the number that's by itself. That's negative 2. Okay, so I'm going to go ahead and graph that. So I'm going to go down a little bit. So graph negative 2, 0, negative 2. I'm going to go down 3, right 2. I'm going to go up 3, left 2. If I go backwards, up 3, left 2. And this is a dashed line. Now the shading, I shade below this line. And so once again, we're looking for the overlap of shading to identify the solution to these two equations. The solution to the two equations. My second equation is x minus y is greater than or equal to negative 3. This is going to be a solid line. I already know because of the greater than or equal to. Put a 1 in front of there and a 1 in front of here. Subtract 1x on both sides. and I get negative 1y is greater than or equal to negative 3 minus 1x. I divide both sides by negative 1 to get rid of the negative in front of that y. And y, flip over the symbol, is less than or equal to 3 plus 1x. Now, I'm going to rewrite my equation over here. Y is less than or equal to, I'm going to put my x term first, 1x plus 3. I'm shading down, and my slope here is 1, and I want to make it a fraction, so 1 over 1. B is positive 3, so I'm going to go ahead and graph that. I go up 1, right 1, up 1, right 1, make a point. If I go backwards, down 1, left 1. Okay, now this is a solid line, and I'm shading below the line. Shading below this line, and the first thing I see is where the overlap is. That's the green portion. That's the solution to this system. I like this portion of any systems of equations the best because of the shading. It looks fancy and it looks fun. Anyways, so here's my solution to both systems. Is this shaded area. It's all the points in the shaded area. Okay? Now, so this is write the inequalities for the system. So first, we're going to have two lines. So we're looking for our symbol. We know what y is. We're looking for the symbol. We're looking for the slope, and we're looking for the y-intercept. We're looking for the slope and the y-intercept and our symbol. So we need to decide how we shape for each line. So I'm going to number these lines. This is number 1. So this is my first y. This is number 2. This is my second y. Okay, so number 1, my y-intercept is right here. It's at 2. It's at 2. Okay, so I'm going to replace b with 2 plus my slope. My slope here, I'm going to pick another good point. Here's another good point, and I go up 2, right 4. So my slope is 2 over 4. So m, I need to simplify this. I need to simplify that. Let me grab this real quick. So let me do this. So m equals 2 over 4. Simplifying, I have 1 over 2. 1 over 2. Now what's my symbol? Am I shading above the line? For the solid line, it's shaded above, and it's solid, so it's equal to, and it's greater than. Y is equal to and greater than. Okay? Now second line, my y-intercept is down here at negative 2, so I'm going to replace that b with negative 2. My x comes down, of course. Now my slope, if I start here, create a right triangle, I go down 2, so down 2 over 1. So m here, negative 2 over 1 simplifies to negative 2. So negative 2. Okay, my shading, it's shaded below, so it's less than, and it's not equal to because there is no solid line. It's dashed. Next, you do have the lesson 5 homework. So I'm just going to go through this homework with you. So I want to talk about what you have here. So we're shading, the shading for this is always, the overlap of shading is always your system. I mean your solution. But the first problem is whether or not a point makes this system true. So does this point x and y make the system true? So you test whether it's true. So 3 parentheses -4 plus 2 parentheses 2, is this less than 4, question mark. When you insert these points, these coordinates, is this statement true? So -12 plus 4 is less than 4. Is -8 less than 4? This is true. Okay, so we check the second equation. We have x plus y is less than or equal to 3. So is -4 plus 2 less than or equal to 3? Is -2 less than or equal to 3? This is true. So we can conclude -4, 2 is a solution to the system. This is my answer. -4, 2 is a solution in this system. Okay? How do we do that graphically? That was algebraically. So we go and check our coordinates x and y. We go left 2, down 3. So left 2, down 3. Is this in the shaded area? -2, -3 is not a solution in the shaded area of the system of inequalities. Okay? Now, lastly, rewrite the inequalities for each system. So I know I need my slope. I need to change these equal symbols. I need my y-intercept. So here's equation number 1. Here's equation number 2. Equation number 1, y-intercept's at -3. So I'm going to change b to -3. And then my y-intercept, I go up 2, right 3. So 2/3 x. The shading for this is right here. This is the shading. So it's below this line. So it's less than, and it's equal to. Okay? Equation number 2. My y-intercept is at +2. Okay? And I go down 2, right 2. So m equals down 2, right 2, or -1. So -1x. And this is above the line, so it's greater than. It's greater than. There's my 2 equations there. I'll let you finish off with number 4. You're looking for your symbol. You're looking for m, and you're looking for b. Just make sure you drop down your x. Hope that was relatively straightforward for you. On the next page, number 5 and 6, I'm going to go over those with you. So number 5, I have a slope of -3. I want to make it a fraction, so over 1. b equals 3. So I go plot my y-intercept at 3, and I go down 3, right 1, down 3, right 1, and this is a dashed line. Y is less than, so I'm going to shade below the line here. Shade below the line. I don't shade the line itself, just shade below the line. Now, for my second equation, I have my slope is 0. Y-intercept is at 2. So slope 0, y-intercept at 2. So this is a horizontal line where all y values are 2. All y values are 2. Okay? And what about the shading? Well, let's look at it's greater than. So it's above the line and it's on the line. So I'm going to just write what where all of the solutions are for this particular system. So here's the system solutions. But what about the yellow portion? Well, this is y is less than negative 3x plus 3, and the remainder of this is where y is greater than 2. Okay? And the green portion is where they converge. All right? For number 6, we have x is less than 2. So this is a vertical line. This is a vertical line at 2. This is a vertical line at 2. And it's not solid because it's not equal to, so it's dashes. Now, where are all the values less than 2? They're to the right of this line. They're to the right of the line. All values less than 2 are to the right of the line. Now, for the next line, we have x is greater than or equal to negative 3. So I'm going to go to make a vertical line at negative 3. And it's equal to, so it's solid. So the overlap here is going to be in the middle of these two vertical lines. So you need to be cautious and careful with vertical lines. But if I want to identify the system solutions, here's all the system's solutions. This shaded area is all the solutions of the system. For number 7, it's going to be similar. Identify the slope and the y-intercept. Number 8, you have to solve for y and then identify the slope and the y-intercept. Hope that helps. Next class, we'll be doing the review for this.